So I noticed a subtle oddity that I discovered when I was messing around with the java.util.concurrent package. I was looking for like just a time-taking method that could just do something for a little while and then stop doing that thing, just so that I could test some parallel processing to see how Java handled multi-core stuff. But this oddity was happening when I went through some very simple code like this. Just loops through, does a long operation, and just loops through as many times as possible. And you'll notice that if I run it, that what happens is, as soon as it loads up, it shows that 5 milliseconds were taken to perform this entire loop. T1, system current millis, T2, system current millis. The difference is 5 milliseconds. This is a good 2 billion iterations here. You would expect this to take longer. Now, I thought to myself, this must be some kind of a programming error on my part. It must just not be executing this loop because of some failure on my part to code it up right. But as you can see, it's quite simple. It just goes from integer min to integer max and increments. So it should be, by all rights, going through this loop. Now, I have subsequently found out what was going on with this, and I will say that I have managed to replicate this in Java 7, but not in Java 8. So if you go here to this project, or if I go to here to this project that I've designed to run on Java 8, it's the same code, and if I run it, it will actually undertake to loop. So it's taking a while, and it's churning through, and I've actually also had it spit out the version of Java, just to be clear. It took 12 seconds, 12,065 milliseconds. Now, I've been through this many times, and the only conclusion I can come to is that in Java 7, Java skips running the loop under certain very specific conditions. Primitive operations only, like the long thing there, and no function calls are made inside of this loop. Furthermore, the actual result of the double or the primitive functions should not be read at any point. If it is read, then this goes back to actually executing the code. So if you notice for a second here, I'll just run it again. Java 7, time 4 milliseconds. But if I say system.out.println d equals, then say d, and then run that, you will see now it's taking this loop seriously. So it seems like some kind of an optimization strategy on the part of the Java 7 virtual machine. And obviously this is pretty misguided because it doesn't do quite exactly what the programmer would reasonably expect it to do. Now, it's harmless in some ways because if nothing reads D, then there's no bad result coming out of this. There's no bad data coming out of it. But I imagine, with some credulity stretched, perhaps, that you could imagine that variable is being accessed in some other way. There's a million other little permutations that you could try. I would just say that I did try one with math.random, just to show you that that calling a function will make it iterate through the loop too. In fact, this will make it take quite significantly longer, so I'm going to actually just stop it from executing. But one exception to this is actually math.squareroot. Math.squareroot will not cause the loop to actually execute. If I run it, again we see 5 milliseconds. What is the difference between obviously I know what the difference is between math.random and math.squareroot, but it must be somehow reducible or reduced in the creation of the bytecode to some simpler function or something like that, because math.squareroot is also a function call out to some other place. So that's a wrinkle that I have not really figured out at all. If I wanted to solve this, I would probably figure out how this compiled into bytecode and look up the specifications for these virtual machines. I'm sure it would vary by virtual machine. But I just thought I'd bring this up because it's something that's really puzzled me, actually.